relational algebra. So relational algebra is a fundamental of the SQL. So actually, when Dr. E.F. Code proposed the new database model, okay, at the time that he defined what is a relation, what is a constraint, to specify the condition of the relational model. And also he proposed the idea to operation. So why don't we go back to the chapter 2 when we discuss about the modeling. When we define the model, what is a model? Model is the set of rule or concept. Okay. Also we need the operation to use that the model classes. Think about the object-oriented model. Object-oriented model, that after we define the object class, then we define the operations, the method, okay, that can access, because due to the nature of the object is encapsulated, okay, it's an abstraction level. So using the encapsulation, so we can implement the abstract, the characteristic of the object. But how can we access the data in the object? How can we use the structure of the object using the method? Okay. Similarly, after we define the relation, what is a relation? Relation is the two-dimensional array, like the table. Okay, a group of data and also group of attributes, and also with several conditions, constraints. So key constraint, the entity integrity constraint, as well as the referential integrity constraint. Sometimes depending on the requirement or the type of your database, so it has a built-in, the user-defined the constraint. Okay, so this is our relation. This is our relational database model to represent the employee. Then how can we access the data? So Dr. E.F. Code proposed the several operations. That is called relational operation. So using that relational operation, we should be able to access the data. First one is what? First operation is the basic operation, basic thing we need to do with this table, this relation is what? We need to find the data. Row. We need to find the tuple. We need to access the specific data. That is the first one is a selection. What is the symbol?
Line.
Symbol is we are going to use the sigma. Okay. So for example, the sigma condition, and we have the relation over here. Okay. Then we can specify the specific condition of the tuple. For example, we did the relation from this relation. If we want to specify the DNO is 4, so check the only DNO attribute which is satisfied with this condition. DNO is equal to 4. Yeah, employee. And all the tuple, that is this one, this one, this one. These three will be returned. Okay? After you get the return of that operation, so we have 1, 2, 3 tuple that each of them has the same attribute, which means that is also relation. So we can use the output of any relation as the input of another relation. For example, I have another condition that is the salary is bigger than the 3K. So we can check from this row, and this row, then check the salary. This one, no. This one, yes. This one, no. So only Jennifer will be returned. That is also relation. That is also table. So at that time, we can say the group of relational operation as expression. So we can make the expression that relational expression eventually will be our SQL statement later. So in the phase 2 of your project, I know you didn't have time to do the last step of the phase 2 because that is in the phase 1 you define the query that you are going to implement. the in plain text English. So for example, in our project, I'd like the user should be able to find the ticket between specific time and specific time. Then next thing is in the step 2. So after you make the ER model and convert into the relational model, so you have the relational database model. You don't have to worry about how to create the table yet. We didn't run. Just using your model. Then how can we access the data based on your query that you define? Okay? At that time, you can convert such a plain the query in English into relational expression. So today we are going to cover the rest of the operation. Then you should be able to make the relational expression for your query. Okay? So those who want to revise your page 2, so you can, after this class, you can revise and enhance the page 2, then resubmit. Then GA will accept the resubmission. Okay? So that is the first one. What is the second? Because this is a relation. Relation can be defined as group of data also, group of attributes. We should be able to access the relation, not just only the data by data. We can also access the relation attribute by attribute. So at that time, we can use the projection. So projection means the symbol is a pi. So we can specify the list of attributes from relation. Okay? So for example, so this is an example of the previous one. Okay? The projection, for example, here, so I'd like to get employee. Employee, only last name, middle name, initial, salary. Last name, middle name, initial, salary. This will be time. Okay? So output will be like this one. As you can see, it forms another relation. Okay? Output of any relational operation is also a relation. So because of that, we can make the relational expression. Somebody may get the idea. Right? Can we combine selection and projection?
Yes.
Yes, definitely. So, for example, from here, I don't need the whole attribute of employee. I need only the first name, last name, salary. You can apply. Projection over here. Projection and last name, middle name, initial, first name. And you can get the name of employee who are in the department number 4. You can make any. So the kind of the relational, any kind of query, you can convert any kind of query into such a relational expression. What about the next one? Sex and salary of employee. So we can get sex and salary from employee. So this is the output. However, how many tuples of employee? How many employees do we have? 1, 2, 3, 8. So we have 1, 2, 3, 4, 5, 6, 7, 8 tuples. What about this one? How many? What happened?
Sir, the copy of the data is removed.
Which one? So for example,
Yes.
man 25, female, yes. This one and female 25. Okay. They are identical. It's a duplicate data. What is the definition of a relation? It's a group of data, but it should be unique and not none, right? So, what? The primary key. So, in other words, it should be unique. They don't allow the duplicate data. So, any relational operation, they automatically remove duplicate data. Okay? So, that is the reason we have only one female 25,000. What about SQL later? Structured query language. Have you ever used the SQL before? Somehow. So what happens when you select the duplicate data? It doesn't care. Okay? SQL does not care duplicate one, just return as it is. That is one of the main difference in SQL. Relational algebra does not allow duplicate data, it's automatically removed. However, SQL allow duplicate data. Instead, why? Because the first time they just implement the relational algebra to the SQL programming. This is the modeling, okay, relational operation. This is the language. So it's implemented language, program language. However, people, user complain. I want to get all the data, then later in my application, I'd like to handle it by myself. So because of the SQL is more flexible than the relational algebra. Okay. So then, we discussed that any output of relational operation is also relation. So, which means if we make the example, the DNO is equal to 4 employee, then instead of the relational expression, I'd like to save this one in the temporary space. Then use this one for another relational operation, last name, first name. At that time, we'd better have the specific name of this. Okay? So to address that problem, so we are going to use the arrow as a third one, rename. Rename of relation. Okay, so for example, this is an employee MP underbar DNO4. This is the relation name. Okay. Then we can use this name in the here, DNO5. Then this is the result. Result is the name of relation. So you can rename whenever you want using this arrow. So rename of the relation. Also, sometimes last name and first name is too long to write. I want to change the attribute name LNFN. Okay? So if you want to rename, there are two rename. One is the relation rename, second is attribute rename. To change the name of attribute, we can use row operation. So row operation, so for example here, first name, here you can just list the new name in the same order. So output of this one will be like this. L last name, first name, and the data. Okay, instead of L name and the F name. Okay, so there are two types of rename. One is the rename of relation. Okay, we can use the left arrow. And also, on the other hand, attribute rename is the row operation. Okay, so this is another operation, relational operation. So far we have learned the three. One is the selection, to select the specific data with a condition. Second, projection, to specify the attribute. Also, we can rename of the relation using left arrow, and also rename attribute using row operation. All of these are implemented in SQL language. Exactly, almost the same, except duplicate data. Duplicate data will be removed in other relational algebra, but not in SQL. We will see detail. So this is a rename. So this is an example of the relational expression, because we have 1, 2 operation. What does that mean? From employee, what? Whose department is 5, and retrieve last name, first name, and salary only. So this is the output of this relational expression. Okay. Then also we can rename. If we want to rename, how can we make this one? First, how can we make the temp? We can, from here, from employee, we select DNO is equal to 5, rename is a temp. Okay? Then, what about this one? From here, from the temp, so we apply the projection first name, F name, last name, L name, salary, from temp, and rename with first name, last name, and salary. Then this is the output result. Then you can get this one. It's the same thing, same data, but different the representation. Okay. What about in SQL? Yes, SQL has all these functionality. We will see during the chapter 4 and 5. Okay. Any questions so far? So far so good. It's not very complicated concept. Okay. Then so far, how many input relation? Selection, how many input relation? One?
One.
Two? So one.
One.
What about the projection? How many? One. And what about the row operation, rename operation? It's one. Okay? So this relational operation is called unary operation because the input relation is just one. From now on, it's a binary operation, which means input is the two relation. Also, among them, because the relational algebra, the model comes from where? Set theory. So, one of the benefits of using such a set theory is we can utilize any set operation using the set theory in our relational model. So, first, union. So, do you remember the what kind of set operation you learn? Union. A union B. And A intersection B. And A minus B. So for example, using Venn diagram, so this is all of this, and this is this one, this is belongs to A, not only the B. Okay? So this can be used for relational algebra also. So these are the table. Relation, this is another table. We try to get the tuple belongs to any of these, so both of them, or only for this. So that is a union operation. Okay? So what does that mean? To retrieve the social security number. So we need the social security number of all employees. Okay? We need that means we need to apply the project operation is somewhere, right? So we need to get the social security. All employees who either works in department number 5 or directly supervise an employee who works in department 5. There are two conditions. It's the or condition. Or means we can use A union B. At that time, we can use the union. First, you can implement the relational expression for this one. Works in. That is simple. Okay. Select only employee. DNO is equal to 5. Okay. Then we need what? Social security number only. The next one is directly supervise an employee who works, which means supervises. So supervises. DNO is equal to 5. Okay? That is the from the department, this one, Okay? Who belongs to this one? Who's a super SSN? We can get the supervisor SSN. Okay? Then that means any employee who supervises the DNO file. Okay? Do you understand what does it mean? So this is a department. This is the employee for file. So we need this employee plus who supervises this employee, which means there is a super SSN. Why don't you remind the relational model of the relational diagram for company database? So we need the SSN union super SSN. That is this one and this one. Then it's all employee. So we can reject one and reject two union. Is that the only way to access the data? No. There are many others ways. For example, why don't we apply this and this projection layer after union? Then you can do that. Okay? And also different order. So in relational algebra later we will see such a problem. When we access the data in relational model, there are many different ways. I'd like to use the example of the travel. For example, I'd like to travel to Manhattan from Bridgeport. How many different ways? So many different. You can use the MTA, and you can use the bus, you can use the motorcycle, you can drive by yourself, and also you can take the flight or helicopter from the New Haven. Or you can go to the Boston, or you can going around the opposite way of the earth. Okay? Anyway, that's the way. Among many different ways, we need to find fastest and also reliable way. That is the problem of query optimization. So when you make such a relational algebra expression, first you don't have to be serious the performance yet. Okay? It depends on the condition. How many data are there, and how big is that, and how they are related. However, try to your best. Okay? Just based on common sense to make the reasonable relational expression. Also, it's the same problem in your exam. As long as the output is correct, no matter what, if relational expression you make, it's okay. Okay? So, but that's because of that, I try to give the several conditions for my convenience. Otherwise, I need to test all of different questions. So, but try to your best based on the common sense. Okay, like the traveling, take the flight the opposite way, going to India and Korea, then the LA and the Manhattan. No, nobody takes that way, right? So please, the reasonable, the relational algebra expression. Okay, that is a union. So it's a straightforward. We can have the union example here, but when you union two relations, we have the two relations. One is a student, another one is an instructor. When you combine two relations, it is the obvious. Their attribute should be matching. Okay? It doesn't have to be exactly same. Okay? But match. What does it mean? Matching. It's a type comparable. So when you use the programming language, high-level programming language, even though the A plus B, A is integer, but B is float number. Some of the program language automatically convert the integer to the float number. Then they can add. It's because they are automatic type comparable. But some of the very strict the program language pop up error. But here, when you the union or intersection, any the set operation, it should be type comparable. Type comparable does not mean the exactly same attribute. So for example, this is the not F name, company name. For example, it's just an example, but it can be type comparable. Because it can be, it does, semantically doesn't make sense. However, in terms of type comparability, it can be added. However, if we have the middle name initial here, then union in student instructor, no, you cannot do that. Okay? Because it cannot be matched. Also, if we have the integer, not integer, social security number here, no, this is a different type. So we can union this one. One more important thing is how many students? 1, 2, 3, 4, 5, 6, 7. How many instructors? 1, 2, 3, 4, 5. So it's supposed to be 12. However, we have 10. Why? Because some duplicate data will be automatically removed due to the characteristic of the relational model. Yes?
So if we have first name, last name and social security number in student table, what will happen if we want to see every data, like the common one and the uncommon one?
So that will be discussed in the join. When we discuss about the join, his question is what if we want to all the data, and when we, for example, intersect, okay, we want to get all the data left hand side.
Intersect means?
Is it your question?
So intersect means the common data?
Yeah, common data. Are you asking the common data to get the common data from the voice?
I'm asking about the data that are also common and uncommon. That like in union we should get everything.
Yeah, union we can get everything. What about the common data? We can use intersect. What about the non-common data from left hand side? Which means the Susan Yao is here. No. The Ramesh Shah is not so here. So it's a common. Johnny Collar not here. So I'd like to get this. The Barbara Jones, yes, I'd like to get this. So how can we get such a data? Using minus. Okay, that is the definition of the minus. So we will see the more example here. So this is the union. Student and I don't think it's a union. It's an intersection. It's a mistake. Okay, and this is the minus. Okay, only in left-hand side student. How can we get only in instructor? Instructor minus student. Okay, that is this one. Then always you need to check the duplicate data. However, there might be no problem in
Relational.
this one. Because automatically there should not be the duplicate. Only union you need to be careful. Okay, and also it should be so when you are using the binary operation and the set operation, type comparable and duplicate data, you should be careful. Okay, so that is however, what about the minus? Actually, minus can be defined as using, oh no, that's the last thing, not minus. So in set operation, so there are some characteristics like the associative. Associative means we can operate the first one and the last two, there should be the same. Okay. However, minus is not the commutative, as you know. So you can be careful to use this one. Okay. So we learn rename, left arrow, and the row operation, and also we learn the set operation, union, intersection, minus. The next one is the very interesting, the operation. Do you remember this one? It's a set. What is A times B? Did you remember such a question? It's an all combination. 1A, 2A, 3, and B1, B2, B3 and this. What is equal? It's a Cartesian product. Cartesian product is the all combination of the element from two set, two table. In this case, in our relational model, A represents what? Tuple. Another tuple. Tuple, tuple, tuple. So, when we combine two table, two relation, we can use Cartesian product. For example, so we have, let's say, the table, two relation. One is the female employee, another one is the employee names. So we have the, no, not that one. Like this, the employee name. Cartesian product, employee. So we have the employee. Employee is the same as this one, but all employee, 8 employee. So from the first name and middle name initial, last name, and we have 8. So Cartesian product means this plus Elisa, Jeremiah, okay, Elisa, Jeremiah, 99987 plus this the first tuple, Elisa, Jeremiah, and 9998. And also it has all this information. That is this one. Okay? So this is the from this, and this is from, I think it's a dependent table, not employee. It's a dependent. Dependent. Okay? ESSN, dependent name, sex, and birthday, and other attribute of dependent. So we can just combine like this one. And next, this Elisa Gerard 99987 with the next, okay, dependent. And next one, next one. So how many dependent we have? 1, 2, 3, 4, 5, 6, 7. 7 dependent for Elisa Gerard with the 7 dependent name is combined. For the next, Jennifer and all dependent. And Joyce and all dependent. So we have set 3 and 7 data. Total how many tuples over there? 3 times 7. All combinations. So it's total 21 tuples. That is the Cartesian product. Then, however, what we want is the employee and their dependent. So which means Elisa Jeremiah 9987 is not related, okay? Because their ESN, SN is not the same. So what we want is 99998877 is not here, not matching. But Jennifer 9877, this one is matching, okay? And Joyce 456, 456.